So ladies and gentlemen, now is the part for the assignment, renal clearance assignment. Yes, renal clearance practice assignment. Here we have a drug which has a pK of 4.9. Drug is eliminated by both renal and hepatic pathways. So it eliminated by renal and hepatic pathway. Suggested the dose of the drug in the normal renal and hepatic function. The patient with normal renal is this, and administered every 12 hours. So first we have to read the important information. PK 4.5, the dose is 5.6 per kilo and administered every 12 hours. And then we have some information. We have clearance. This is clearance. Clearance, that means total clearance, not renal clearance, hepatic clearance. This is renal plus hepatic clearance. Urinary excretion, Fe, fraction excreted is 0.075. Oral bioavailability this, and unbound fraction Fu is 0.2. So now we have to do some calculation. Total clearance. Total clearance is easy. This is in milliliter per minute per kilo. So total clearance would be what? Easy thing to do. Total clearance would be clearance, which is given in minute per, this is, you see here, it is in milliliter per minute per kilo. So is patient's weight. Then you calculate. Our clearance is 1.42 milliliter per minute per kilo times patient weight is 70, which is 99.4 milliliter per minute. So this is our total clearance. Total clearance of the patient. So here it is 99.4 milliliter per minute so this is our answer for this. And then renal clearance. Renal clearance is, if you remember, renal clearance CLR, total renal clearance, will be Fe, fraction excreted in the urine, multiplied by total clearance. So, just for clarification purpose, as you know, this CLR is total renal clearance, okay, which involves filtration, secretion minus reabsorption. This is called total renal clearance. And this one, CL, is total systemic clearance. This is very important, which involves renal clearance plus hepatic clearance plus others, for example in the GI tract. So this thing you have to remember, and the CL we have calculated is this is that. Okay, so now let's do the calculation here. CLR is equal to Fe times CL total is going to be is equal to 0.70 here. See Fe 0.0754 times 994 milliliter per minute which is going to be 7.49 milliliter per minute. This would be your total renal clearance. So yes, let's put the answer here. Total renal clearance is 7.49 milliliter per minute. It is renal clearance. Now hepatic clearance. Hepatic clearance is easy. This CLH, if you remember, CLH, we have to find out fraction hepatic clearance. So CL, this is this, CLH is equal to fraction hepatic is 1 minus Fe times CL, which is total. So 1 minus Fe is 0.0754 times 9.994 would be 91.91 milliliter per minute. Okay, so this is our hepatic clearance. Hepatic clearance is 91.91 milliliter per minute. And then filtration clearance. Yeah, that's the equation I have been talking about in the class. Filtration clearance, which is filtration. Let's see, filtration clearance. If you know CLR, filtration is equal to what? FU times GFR. So FU times GFR. FU is 0.2 and GFR is what? You see here, it is GFR is 1.20 milliliter per minute. 120 milliliter per minute is equal to 24 milliliter per minute. 24 milliliter per minute. So we have here. So filtration, what mechanisms? So this is our filtration clearance. This is CLR by filtration. What are the mechanisms absolutely involved in the renal excretion of this drug? So first we have to see what is the renal clearance. Renal clearance is this. Okay. Renal clearance is this, but filtration clearance, this is our total renal clearance. Just remember, filtration clearance is this. So we have to answer this question, you have to do some thinking and read the note first. So our CLR is equal to 7.49 milliliter per minute, and our CLR filtration is what? 24 milliliter per minute. So our CLR is less than CLR filtration. So only this thing can happen, or what? I'll try to figure out. That means with the glomerular filtration, that drug that much was filtered and then it decreased. What happened? In case of decrease, it must have tubular reabsorption. That means although this much was filtered, although 24 milliliter per minute was filtered, but renal clearance decreased, total renal clearance decreased. So there would be some filtration. So filtration and plus reabsorption. One cannot be. So what would happen in case of if there was it was less than that, then there would be answer would be this one. Or maybe there is question like this or later. So based on the mechanisms absolutely involved renal clearance, do you expect the changes in the renal clearance as a result of co-administration of proven acid and cimetidine? So proven acid, and the question is asking you to tell that based on the mechanism absolutely involved. So here we have, what are the mechanism involved? We have mechanism involved is filtration, plus reabsorption. So reabsorption, tubular secretion secreting agent, like so what is going to happen in case of, first of all, you see this is a weak acid, this is a weak acid, and we have taken co-administration proven acid and cimetidine, co-administration of proven acid and cimetidine. So tubular secretion is not involved in this case, you see, because we know that based on this there is no tubular reabsorption. So in case of, sorry, there was no probular secretion, we didn't see with it happened only tubular reabsorption. The proven acid and cimetidine, this only modulate secretion. So this drug proven acid and cimetidine can influence tubular secretion, not reabsorption. So for this reason answer is no with either drug. So neither proven acid or cimetidine can influence the elimination of this drug. But based on this may involve elimination. What happened to renal clearance if the drug urine is made acidic by ingestion of ammonium chloride? What would happen if is ingestion of ammonium chloride? So ingestion of ammonium, this we know that we have reabsorption. Okay, we have reabsorption in this drug. Reabsorption is involved. We know that from here. From this answer, we know that reabsorption involved. That means when reabsorption involved, acidification, changing the pH will influence reabsorption. So in this case, pH is made acidic. Our drug is acidic. Our drug is acidic. You made pH also acidic. Okay. So you are making the pH, so making the urine more acidic will increase tubular reabsorption. So the clearance, what is now it is going to happen based on the absolutely, what would happen to the renal clearance of the drug? Renal clearance of the drug, clearance will decrease. Clearance is going to decrease because reabsorption is going to increase. Okay, clearance is going to decrease, so the clearance is going to decrease. Here just let's go back again, this may confuse you. Based on the mechanism absolutely involved renal elimination, what would happen to the renal clearance of this drug if pH is made acidic? increase is made acidic, that acidic pH will increase reabsorption. When reabsorption increases, if you remember, when reabsorption increases, the amount of the drug is going to decrease in the urine. So in this case, the renal clearance is going to decrease, not going to increase. Then what is the steady state concentration of CSN of the drug? What is the average steady state concentration of this drug? To calculate this average steady state concentration, we have to use this equation. C average is equal to Fs dose by and clearance. So and I think F is there, yes, 0.735. F is 0.735. F we will use 1, and dose you have to calculate like that. It is 5 point, let's see, this one, 5.6 milligram per kilo times 70, because it's divided by 12 every 12 hour, and then if you convert to 60, so this is minute. So this is your dose, and this is tau, and divided by CL, which is 99.4 milliliter per minute, and this would be 288.12 milligram per minute divided by 99.4 milliliter per minute is equal to 0.0040258 milligram per milliliter, and then you can convert to milligram per liter, will be 4.026 milligram per liter. What happened to my calculation here? Yes, this is here, but it has recorded. So here you again, to make things clear, it has disappeared, you have to use this equation. Sorry, you have to use this equation to calculate. Okay, there are some issues with my computer. I don't know why. What's going on again? Please. It is restarting. Here again. Sorry, what's going on? I don't know with my computer. So this is the equation you have to use. C average. Let's draw this. You have to use this equation. C average, and then C average is equal to F S dose by tau divided by CL, and this will give you an answer. This will give an answer of Finally, if you want to convert, is 0.004025 milligram per milliliter, which you can convert to milligram per liter, 4.026 milligram per liter. Four point 0.026 milligram per milliliter. So these are the calculation you have to do, and for these two answers you have to go over the note, so you'll better understand how things works. And then part 3, this 70 kilo 86-year-old male patient with a serum creatinine of this will be treated with this drug. Please estimate the following part. First, we have to calculate creatinine clearance. How we calculate creatinine clearance? You have to remember now some of this information, newer information we have now here. This 70 kilo 86-year-old creatinine clearance is this. So to calculate creatinine clearance, remember that equation we have used. Creatinine clearance in main CR is equal to 140 minus H times weight divided by 72 times serum creatinine level. So this is easy. 146 minus this 86-year-old man times 70 divided by 72 times 3.13. This is 3.13. This will give you an answer is 16.77 milliliter per minute. So this will give you 16.77 milliliter per minute, which is 16.77 milliliter per minute. Renal function as a fraction of renal function in a young healthy subject. So you have to calculate renal function. So how we are going to calculate renal function? So we know renal function equation. What is the renal function equation? I was teaching it in the class. RF, renal function, is equal to C creatinine clearance diseased, creatinine clearance normal. So we have the patient is creatinine clearance, we have the new creatinine clearance, which is 16.77, which this is the patient. Okay, and this is a patient, and then normal individual has a creatinine clearance is 120 milliliter per minute, 120 milliliter per minute. Then you will get renal function of 0.1398. This is RF. So now if you have to calculate, we have the renal function. Renal function as a fraction of renal function is, which is this one, 0.1398. This is the renal function. And now renal clearance. So you have renal clearance, and also you have to remember the renal clearance in normal individual is GFR, same as GFR. Here if you see, you may get confused, as GFR of healthy individual is, it was 120 milliliters. Always you have to use that one. And renal clearance of this individual, we have to calculate. How we calculate? CLR would be renal function in healthy individual. That is renal function times CLR of healthy subject. So CLR healthy. So to calculate CLR of healthy, we have to get this thing from part 1. CLR of healthy was what? I'm clearing this one. This is the healthy individual's CLR. So now we know renal function is 0.13977 times 749,476. This comes from part 1, and this is going to be 1.0476 milliliter per minute. And clearance is going to be this. And clearance in this patient is going to be 1.0466 milliliter per minute. And the total clearance would be what? CL is renal clearance plus CL non-renal clearance, and we have calculated non-renal clearance above, which is non-renal clearance as well, this one. So we calculate this part, total clearance, CL total would be CLR plus CL and R. CLR is this one, the new one. CL total, this one is 1.0476 plus 91.9052, which would be 92.9528 milliliter per minute. So our total clearance is 92.9528 milliliter per minute. Okay. And then average steady state concentration if the normal dose is administered to this patient. So again we have to do the same calculation using this clearance. The calculation is same as above. You have to use just normal clearance. Here C average is equal to F times S times dose divided by tau divided by CL total. This is always total. So we have to use that new CL total. If we know that F is 0.735, we use 1 for S, and then 5.6 milligram per kilo times 70 kilo divided by 12.60, and CL total, new CL total is 92.9528, which will give you 4.305 milligram per liter. This would be your steady state concentration in this patient. See, average is going to be 4.305 milligram per liter would be steady state. Now a new dose in milligram to achieve CSS as in normal individual. Assume the same dose interval for the patient. So now it is asking for your dosing interval. That means use the same equation, but you use the same equation, just rearrange. You have to calculate dosing rate first. What you have to do? Dose divided by tau is equal to C average times CL total divided by F times S. Target C average you have to use from the our, I think, what was that answer? Target C average we have to use from this part, I think. Here, this was the, say, what is the steady state concentration? It is question number 8. Here we had 4.026 milligram per liter. So we have to use this to calculate here C average. So our target C average you have to use from liter, and it was in terms of milligram, it was 0.0040258 milligram per milliliter times CL total. The new CL would be 92.9528 milliliter per minute divided by F, which is 735 times 1. This will give you a dosing rate of, this would be your del dose by tau would be 0.50913 milligram per minute. Now if you want to calculate the dose, this is dosing rate, is milligram per minute. If you want to calculate the dosing rate in every 12 hour would be 0.50913 times 60 times 12 would be 366.57 milligram per 12 hour. So this would be new dosing rate. This would be your new dosing rate is 366.57. As you can see, like our hepatic clearance assignment, we have two parts here. Part 1, which talks about healthy individual, and part 2 talks about an elderly patient whose clearance has gone down. Based on this, what dosing adjustment you have to do. These are the calculations you have to do. So you have to go back sometime to use this data from here, and then also sometime use this new data based on the CL when you are considering to calculate dosing rate for this patient. You have to use always clearance of this patient, and to adjust the dose always you have to use the reference is this one, healthy individual. So this is all I have, and this would be due on Monday just after the Thanksgiving midnight, Monday midnight. I will send an email.